everyone. So today we are going to be doing divisibility tests, and this is part 2. Okay, now you should already have watched part 1. Okay, but if you didn't, then you better go watch it, alright? Okay, so today we'll be covering divisibility tests for 8, 9, 10, 11, and a bit of 12. Although 12 is not really important, but we're still going to do a little bit of 12, and it's going to be interesting. Now, if you notice, I skipped 7 because we did 1, we did 2, we did 3, we did 4, we did 5, we did 6 last lesson. Actually, that's the 1 now. Okay, we did these last lesson, and this lesson we did these. You notice that we actually skipped 7. Now, 7 actually also has a divisibility test, but it's not really part of the syllabus. You have to learn it. It's not important, and it is a bit more advanced. So if you want to learn it, you can go and search it up. Okay, but today I'll just be teaching 8, 9, 10, 11, and a bit of 12. Okay? So let's start. But before we start, I want to set something clear first so that you guys know what to expect. I mean, not exactly know what to expect, but so that you guys at least know this basic thing. I actually covered this in the last video, but just in case you didn't watch or you don't have time to watch, I'm just going to cover it one more time. Now, if you have an integer ABC, it will be equals to 100a plus 10b plus c. Now, a lot of you will be asking me, why is this even important? Now, because in divisibility tests, I will also be covering the reason why these divisibility tests work, which is why it is so important to make sure that you listen up. Okay, I'll also be covering the reason. It's not just like, hey, the divisibility test for 8, you just need to do this and you will know whether it's divisible by 8. No, I'm not just going to do that. I'm going to cover the reason. That's why you will probably think, why is this video so long? Because I will be covering the reason for all of that. Okay, so that will basically is something you need to know first. Okay, so if we have something like AC, that will be 10a plus b. If we have A, B, C, D, that will be 1000a plus 100b plus 10c plus d. Okay, now start. Now divisibility test for 8. Now it is similar to 2 and 4. Okay, now I'm gonna let you guys think about this one. Okay, divisibility test for 2 is like this. 2 is last digit must be divisible by 2. Divisibility test for 4 is last 2 digits must be divisible by 4. And for the reason for the 2 is because if you have like ABC, 100a plus 10b plus c. We all know that 10b is divisible by 2. This is also divisible by 2. So it's all up to this. Alright, I've actually explained this, but I'm going to explain it one more time. For divisibility test for 2, we know this is divisible by 2, this is divisible by 2, so we don't have to care about it, we can completely ignore it. It's mainly just this. Is this divisible by 2? That's the question you have to ask yourself. Okay, so that's why you just look at the last digit. Okay, the next one. You have 4. Now, this time, we look at the last 2 digits, which basically is B and C. Why? Now, this one we don't have to look at it because this is actually divisible by 4. And anything in front, if we have like 1,000, if we have 10,000, it's all divisible by 4. So this is divisible by 4, so we can ignore it like how we did with 2. But we cannot ignore this 10. Now, for the divisibility test for 2, we actually ignore this 10. But we cannot ignore this 10 this time because 10 cannot divide 4. So instead, we have to actually not ignore it. We have to actually look at D, we have to actually look at C. Which is why it's the last 2 digits. How can you guess the thing for 8? Pause the video, think about it. Welcome back. So, do you think of anything? Now, as many of you may have already guessed, it's last 3 digits. And I want you guys to contemplate the reason why. Now, just like how it worked for 2 and 4. For 2, we just need to look at this because all these are divisible by 2. Right? For 4, we just need to look at these because the others are all divisible by 4. Now, for 8, we need to look at all these 3. Because 1,000 is divisible by 8. And anything in front, you have 10,000, 100,000. Okay? Because, you see, 10,000, I mean 1,000 is divisible by 8. Therefore, 10,000 must be divisible by 8, right? And anything that ends with 1,000. If 1,000 is divisible by 8, Now, let's say I have the number A, B, C, D, E, F, G. Then that'll be like, this is 1, this is 10, 100,000, 10,000, 100,000, 1,000,000. We reach a million. But we know 1,000 times 1,000 equals to a million. So that it still constitutes a part of 1,000. So I'm pretty sure I've actually covered this in the previous video, so you can go watch it if you don't fully understand yet. But basically, anything in front, they can all be divisible by 8. Okay, so that's why we don't have to worry about anything in front. But there is something we need to worry about these. Because unfortunately, this cannot divide 8, this cannot divide 8, and this also cannot divide 8. And you really have to see whether it can actually or not. So you need to look at the last 3 digits. So that's pretty straightforward. Okay, now let's look at divisibility test for 9. Okay, now it's super similar to divisibility test for 3. And I will cover the divisibility test for 3 again. Look carefully. We can agree on this first. All these divisibility tests, almost all of them have the same principle of this. Okay, so you need to make sure you know. Let us break up 1,000 into 2 pieces. 999 plus 1. 8. 99, sorry, plus 1. B. 9 plus 1, C, and just D. Okay, now, let's expand. I'm pretty sure you guys know what's the expansion, right? Sure. It's this distributive law. I'm pretty sure you guys know. So it'll be 999A plus A. 99B plus B. 99, 9C plus C and D. Why? A times 1 and also A times 999. B times 1 and B times 99. C times 1 and C times 9. Okay, now this, sorry, this, and this. Okay, we literally just need to take 999A, 99B, 9C, and we take all the things that I circled in purple, we move it to the back. As I'm pretty sure a lot of you have guessed, we can ignore this because all these are divisible by 3. So we just need to look at this. The sum of digits. So divisibility test for 3 is if it adds up and that value is divisible by 3, the entire thing is divisible by 3. But you notice something. 999, 99, and 9. They are all also divisible by something else. Which is what? 9. So divisibility test for 9 is super similar to divisibility test for 3. The digits add up to divide 9 is divisible by. Okay, now let's go through divisibility test for 10. Although I'm pretty sure a lot of you probably already know, but I'm still gonna go through just so to check. Okay, now I don't think there's much to explain for this, right? Let's do a little experiment. 10 times 2 is 20. 10 times 3 is 30. 10, sorry, what? 10 times 4 is 40. 10 times 5 is 50. What do we see? So I'm pretty sure it's obvious that as long as the number ends with a 0, it's divisible by 10, right? But if you really want a super mathematical example, like not just this little listing, I can give you a super mathematical example. If you have, alright, if you have A, B, C, 0, right? A, B, C, 0. That will be 1000A plus 100B plus 10C plus 0. Agree? And these are divisible by 10. And 0, you may say, oh, 0 is not divisible by 10. But technically, I regard him as divisible by 10. Because 0 is nothing. So there isn't a value to it to divide 10 or not divide 10. Which is why we can disregard it. So we don't even look at it. So if you look at this, all these are divisible by 10, so it works. So that is literally why. But honestly, you have to even know, you have to even think of that. Right? Because, okay, hear me out. If A, B, C, D, we know is this, right? Now, these are all divisible by 10. Divisible by 10. So we just need to look at this. But if this is also divisible by 10, aka 0, which is 0 can disregard, then hey, we don't have to do anything. Then hiding divisible by 10. So just to make sure the last digit is 0, because 0 you already know if it's like ABC0, right? ABC0. I mean like, okay, I mean another example. I'm just give an easy example. A0 is basically 10A plus 0. And as I said just now, this is divisible by 10. Okay, so it's like pretty easy example, right? And as we did just now, we can clearly also have an example of how no matter how you times it, whatever you times, you will always end up with something that ends with 0. Because it's, I'm pretty sure you all know the hack. If I give you like 20, 280 times 7, see what that is. You know the hack is basically just take 28 times 7, 14, 19, 196, and then just add another 0 behind. Okay, because this 0 is the thing that sort of identifies it as 10, like a 10. So this you can sort of disregard it. You can sort of disregard it and just take this and times this. And once you get your answer, you just throw in a 0. Because this 0 is just an extra thing. Just right here, like a 10. You know, I need an extra 10. Okay, but it doesn't really matter. I'm pretty sure you guys know. But next one, divisibility test by 11. Okay, sorry. That was weird, but okay. Divisibility test by 11 is going to be very interesting. So, this one is actually a bit tougher. And you need to listen up. Okay, so for divisibility test for 11, I want you guys to think what could possibly make a divisibility test for 11. Like, if you look at the previous cases, there doesn't seem like much that could possibly make a divisibility test by 11. Now, firstly, I will tell you what a divisibility test for 11 is, and then I will explain why it works. Okay. If this entire thing is divisible by 11, the whole number is divisible by 11. You know, a lot of people like, what's A plus C plus minus whatever. Okay. Now, it's basically the sum, the difference of, okay, the difference of sum of odd placing digits and the sum of even placing digits. So literally, it's just sum of odd placing digits minus sum of even placing digits. Difference of that, right? So it's minus. Sum of odd placing digit minus sum of even placing digits. You ask me what odd placing even placing. If I have A, B, C, right? This is how it's supposed to work. Okay. Alright. So this is an odd placing digit, even. Odd, even, odd. Actually, it just alternates. Okay. So just remember the last one, it starts with odd. Just remember that. Okay. So if I have something like this. Okay. If I have an integer like this, remember it alternates. The first one starts with odd, so it becomes like odd, even, odd, even, odd, even. So it's actually hard to. Yeah, I know it's pretty hard to remember which one is odd, which one is even, right? Like, oh, the 10,000 place is what, the million place is what. You have to remember that. Actually, you just remember the last digit is odd. It starts with odd, and then you alternate. So odd, even, odd, even, odd, even, odd, even, odd, even, odd. So I'm gonna do that by different colors. Okay, odd. That even will be red. I mean, sorry, green. So these are all evens. Okay, and these are all odds. So you literally just extract out all the odds. So in this case, I have A, C, E, G, I, and K. And extract out all the evens. B, D, F, H, J. And what you do is, in this case, it says sum of odd placing digits plus the sum of even placing digits. So sum of odd placing digits. These are the odd placing digits, right? Sum. And also take the sum of the even placing digits. And take this entire value minus this entire value, which basically would look something like this. Plus I plus k minus b plus d plus f plus h plus j. I'm pretty sure you guys know that if you take out the bracket, it will look something like this, right? Because of negative symbol, you have to flip over the signs, so everything now will become minus. Okay, that's the rule lah. If you guys don't understand, don't worry, I will also upload videos about negative numbers soon. So basically, it's just a plus c plus c minus b minus d minus whatever, which is basically what happens here. So a quick recap. Later I'll explain why. Don't worry, I'll explain the reason. Quick recap. You have a random number. Remember the ones digit or the unit digit is always odd. And then you go on from there and alternate. So then you take out all the odds together, you sum it out. Take out all the evens together, sum it out, and then take the entire value of odd minus the entire value of even. Now let's explain why. Okay. So let's just use A, B, C, D, E. Okay. Now, I'm pretty sure we can agree on this first. Okay. This is the thing that I've literally been trying to tell you like for the past hour. Okay, not hour lah, but for the past couple minutes. Pretty sure you guys know. Now, the problem is for divisibility test, we want to get something that will help us out. In this case, the 10,000 it is useless at this point. Now, but let me ask you a question. What do you think can be divisible by 11? Watch. If you're smart enough, you should probably know what's going on at this point. Okay? Now, just like how we did for divisibility test for 3. Divisibility test for 3, it was basically you break it up, this one you expand, and you take this, and this can divide 3. And I'm pretty sure you guys can see that this can also divide 11, right? Okay, but we're not done yet. Let's do something that will twist the entire thing. The problem is, you probably think we can just do this for B. But the problem is we can't, because this cannot divide 11. For 3, it's all very good. Everything can divide 3, but in this case, 999 cannot divide 11. But you know something that can divide 11? 1001. So instead we do this. Okay? So it's sort of like divisibility test for 3, just that it's not all of the 999, because in divisibility test for 3, all of that are all divisible by 3, so you can ignore. But in this case, they're not all divisible by 3. But 99, you can divide 11, so okay, let's stick with that. But then, 9 cannot divide 11, so you have to turn it to 11. Sorry, minus is a minus. 1. 11 minus 1, D. Okay, and then E. So, I'm pretty sure you guys can see something going on. Expand. And I'm going to leave it there first. Okay. Okay. Now, these. This is plus an A. This is minus a B. Right? This is negative. And I'm pretty sure you guys can see plus C minus D plus C. And we all know that this can divide 11. If it was 999, it wouldn't be able to divide 11, but since it is 1011, it can divide 11. So, I'm pretty sure you guys know, ignore. Look at this. Is it familiar to you? And if you rearrange it a bit, we get this. And I'm pretty sure this is hella familiar to you. So, for divisibility test for 11, basically, here's the thing. Why do we need alternate digits? Because here's sort of like the reason why. Just now when we did A, B, C, D, E, you notice how the A we could split up into 9999 plus 1. Okay. Why? Because this can divide 11, and we know we have to later do the ignoring thing, which I explained to you about. But this is a little bit of a special situation, because for B we cannot just do this. because this cannot divide 11, so we cannot ignore it, which is why we have to sort of swap it out into this. And this makes sense because this can divide 11. But then you'll notice that this sign will become a minus because it's 1001 minus 1, not 1001 plus 1, because a minus. Which is why you will notice that it's alternation. Right? A minus B. Right? Why is this minus here? Because of this. Plus C minus D plus E. That's why you got all this plus minus plus minus plus minus. Because there are some that needs to be minus. And if you notice, if we have like a big A, B, C, D, E, F, G, H, I, J, K. What the frick? Okay. You notice that it's alternating. This is odd placing, right? And odd placings are the one which you have to do minus. Odd placings are the one you have to do minus. So ultimately you're gonna have to do minus K. And why you have to do minus K? Because of this. 11 minus 1, right? We cannot do 9 plus 1 because 9 cannot divide 11 by 11. That one can. So that is why in the end we are going to have minus K. So notice how it's a bit different because some of them needs to be 999 plus 1. Some of them needs to be 1001 minus 1. Some of them is like a 999, whatever. But some of them is the other way around. And that will determine whether it's a plus or minus. And another thing is, ultimately, when you finish it, you check whether it's divisible by 11. Now, if you get a 0, that also means divisible by 11. Because we've just explained, I've explained just now about I've explained just now about how 0 also counts, right, in the divisibility test for 10. So, 0 works. If you get 0, that means it's also divisible by 11. Okay, last one is divisibility test was 12, which is a bit optional, but you guys can still stay on to listen. Okay, I'm not going to do a re-explanation. I've actually explained this in the previous video. I'm not willing to explain this one more time. Okay, you guys can go watch the previous video. Alright, then you explain. Yeah, you know what I'm talking about. If it's divisible by 3 and divisible by 4 is divisible by 12. Okay, and why? It's because 3 and 4 they are co-prime. I want to explain more about that, but just so you know, divisible by 3 and divisible by 4, you can divide by 12. But it doesn't work for all numbers. If I have something like divisibility test by 4, I can't say, divide 2. Because 3 times 4, we know is 12, right? So we can work. 2 times 2 also 4, so it can work. But, no, that doesn't work that way. Or let's say divisibility test for this. Okay, let me give you a random number. 18. Divide by 6. Divisible by 3. So, it's divisible by 6, divisible by 3. Therefore, it's divisible by 18. No. Because these are not co-prime. But in this case, these two are co-prime, which is why it works. But of course, 8, if you do divisible by 9, divisible by 2, that works. So you'll notice that sometimes some of them is divisible by this, it works. But some of them are going to use the same ideology. And I won't explain why because I've explained it. But you can think about it. Why does it work if divisible by 3 is divisible by 4? That's why it's divisible by 12, but not for some of the other numbers when you break it into factors. Why? I've explained this, you guys can go think about it and then you can go and watch the previous video, which I have linked in the description below, and you can see why this thing necessarily works. Okay guys, so thank you very much for watching. I hope you enjoyed this video, alright, and you know, if you want to watch more of my videos, you can just go ahead to my channel, go watch it. If you like this video, please consider giving me a like, subscribe, and also turn on the bell if you want the notifications, because come on, right? You want to study, right? You want to learn stuff, right? So more videos will come your way, and once a video releases, you'll be the first one, you'll be the VIP to get this. Thank you very much for watching. I hope you liked this video, and if you have any questions, you can drop them down in the comments below. I've always answered my comments. Thank you very much. Goodbye.